Alright, hi everyone, welcome back to the channel. For those of you who don't know me, my name is Priyansh Agarwal. I am a candidate master on Codeforces and a 6-star coder on CodeChef. I also recently got India rank 1 and global rank 6 in Google Kickstart Round A 2022. So in this video, I'll be talking about the topics that people should be doing in order to reach 1600 rating on Codeforces. And there's a very strong reason as to why I'm making this video. Recently, I released a poll on this channel wherein I asked people to tell me, what rating range do they lie in on Codeforces. And I realized that almost 91% people on this channel are less than 1600 rated. So that's like a huge number, right? And that's why I'm making this video wherein I won't be just talking about the topics that you should do in order to reach 1600, but I'll also be talking about the topics that a lot of people less than 1600 are currently doing, but they should not be doing. So I've seen that a lot of people in competitive programming start learning really advanced data structures and algorithms that they might never be able to actually use in a contest. So I firmly believe that if you're learning something, you should learn it only when you think you can apply it, right? So for people who are less than 1600 rated, if you're learning DP optimizations, let's say, then there's a very high chance that you will never be able to use them in live contests, right? So that is one thing that I'll be addressing in this video, and this is something that will be there at the end. So I suggest that you watch the complete video, and there will be a lot to learn from this whole video. So yeah, without any further ado, let's get into the topics that you should do in order to reach expert. Now, even before we start talking about the topics that you should do, there are certain prerequisites that you should have. So you should be really familiar with one programming language, be it C++, Java, or Python. You should also be familiar with C++, STL, or equivalent. For example, in case of Java, it could be Java Collection Framework. Now, let's say you're done with C++ or let's say another programming language, and you're also done with C++, STL, or some equivalent. What next? You should have also solved around, I would say, 100 to 120 problems combined on all of the online judges. Maybe you could have done 30 problems on CodeChef, 30 on Codeforces, and maybe 20 on at Coder. I just want that you don't get into that phase wherein you start learning topics even before your competitive programming journey has started. Right, so it is very important that initially you solve a lot of random problems so that you get to know how online judges work, things about time and space complexity, how the leaderboard thing works, how point system works in contests. So these are certain things that you should know even before you start learning topics, right? With the prerequisites, aside, let's talk about the real topics that you should do. The very first topic that you should do is number theory. You should try to master number theory, as this is kind of the most important topics for beginners in competitive programming. So I've listed down a few subtopics that you should try to do here. The very first topic is modular arithmetic. The next topic is basic knowledge of primes, multiples, divisors. Right, for people who are already in their college, I don't think you need to focus on this a lot because this is something that is covered till high school level. So you should be pretty efficient with this, the primes, multiples, divisors part. The very next thing that you should be really familiar with is called bitwise operations. Bitwise operations are like operators like AND, OR, XOR, NAND, and stuff like that. So there are quite a lot of properties around these bitwise operators itself. So you should try to master bitwise operations just after you have some knowledge of primes, multiples, and divisors. The next topic that you should do is Euclidean algorithm. This is a really important topic, and Euclidean algorithm will also teach you how to calculate the GCD or the HCF of two numbers really efficiently. Right. So the next topic that you should do is called sieve of Eratosthenes. This is a concept, or I would say an algorithm that you can use to find all the prime numbers from 1 to n. The next thing that you should do is called binary modular exponentiation. Let's say I tell you that you have to find out 2 raised to the power 1000 modulo some number. So in order to do this efficiently, there is this thing called binary exponentiation that you can read about. Right. After you're done with binary exponentiation, the very next topic that you should do is combinatorics. Right. Combinatorics is really very important. Even for very advanced problems, combinatorics is something that you should try to master. So these are certain topics that you should do in number theory. Talking about resources, you can refer to this channel called Code and Code. This is like a YouTube channel, and they have a dedicated playlist on number theory. And I can tell you from my own personal experience that this is one of the best resources that are there, for number theory. Apart from that, if you like reading blogs, I would suggest you to refer to this website called C3 Algorithms. You can refer to the algebra section of this website, and it contains a lot of techniques and concepts around number theory. And apart from that, I saw a latest video by Utkarsh Gupta, which is there around number theory. You can watch that as well. All right, moving on to the second most important topic. This is binary search and ternary search. Now, again, ternary search is not really that important for people who are less than 1600 rated. But just in case if you're learning binary search, I would recommend that you also give a look to ternary search and try to understand what happens there. Talking about binary search, the very first thing that you should do is to learn about general binary search. When I say general binary search, it is just referring to, finding out an element in basically like a sorted array. Then you should learn about monotonic functions. The primary reason why you should learn about them is because you can use this technique called binary searching on answer. Right? Binary searching on answer only works on monotonic functions. So when you're learning about these type of functions, you should also be able to prove that if you are given a problem, you are able to convert it to a form that has a monotonic function, right? And you should be really good with proving that the function that you're forming is actually monotonic, right? After that, you should be familiar with certain C++ STL functions like, lower bound, upper bound, binary search, because these are certain, functions which you don't have to implement on your own. They are already available for you. So if you know how to use them, it will be really very helpful for you in contests. Now, coming on to ternary search, I would first of all recommend you to learn about convex functions, right? What exactly is a convex function? This you should be knowing, because the thing is that ternary search only works on convex functions. Then coming on to ternary search, once you're done with convex functions, learning about ternary search is not a very big deal. You can understand the very basics of ternary search, and just in case if you have to apply it in a problem, you will be able to use it. So I haven't seen a lot of advanced problems on ternary search. So even if you learn the very basics of it, you should be in a good position. Talking about the resources for binary and ternary search, first of all, you can refer to this beautiful tutorial on Codeforces Edu section. So Codeforces Edu section is like a small section on Codeforces, and it contains a lot of tutorials on really good, topics in competitive programming. And binary search is one of them. And these are certain tutorials that are taken up by one of the grandmasters on Codeforces, right? And in case you want to do binary search really very quickly in, like 1 to 1.5 hours, then you can definitely refer to one of my videos on this channel, which is specifically on binary search. If you want to, learn about ternary search, I would recommend referring to this website again called CP Algorithms. This contains a really good blog on ternary search, and it not only contains the concepts on ternary search, but it also contains a lot of practice problems on it, right? So I have seen that, there are not a lot of publicly available problems on ternary search. So you can definitely refer to this blog on CP Algorithms, and you can maybe, try out the first 2 to 3 problems on ternary search, and you should be good to go with it. The very next topic that you should focus on is called greedy. When I say greedy, I am referring to greedy algorithms basically. So in order to be really good with this topic, first of all, you need to solve a hell lot of standard greedy problems, right? So you might as well, go on Codeforces and solve a lot of greedy random problems. But I don't think for beginners that is like a really good approach. So when I'll be talking about the resources for greedy, I'll be, specifically telling you as to how you can practice these standard problems, right? Moving on, you should first of all, not only be just solving greedy problems, but you should also be able to prove your solution, right? Proving is kind of the most important thing when it comes to greedy, because let me tell you, when you look at a problem, there might be like 10 greedy approaches that come to your mind, but almost like 8 or 9 out of them will be wrong, right? So if you get on to actually prove your solution, then only will you realize that you're actually making some mistake, right? So if you see people attempting contests, I've seen that a lot of people make a lot of wrong submissions on like the very first few problems. The very first few problems in every Codeforces or CodeChef round are supposed to be really greedy in nature, right? So it is very important that you understand how to prove your solutions, right? You might at times rely on your intuition, but before you actually prove your solution, I don't think you should be submitting the problems, right? So in order to be really good with proving your solution, you might as well look at this thing called exchange arguments. However, this is kind of really optional. Even if you don't know a lot about exchange arguments, you can prove your solutions easily when it comes to problems that are less than 1600 rated. Right, after that, when it comes to actually solving problems, I would highly recommend trying out the searching and sorting section of CSCS problem set. You can do the first 50% problems on this problem set of the searching and sorting section, and you will be really good with greedy, because this contains a lot of standard problems and some standard techniques that you should know. Talking about the resources for greedy again, first of all, if you have to solve a lot of standard problems, then there is a dedicated section for it on Geeks for Geeks, something like something titled as standard greedy problems, and I'll leave the link to it in the description. So when I was learning a lot about greedy, I referred to this one section, and this really helped me. Coming to exchange arguments, I had referred to one of the videos on this channel called Algorithms Live. So this contains a really cool tutorial on exchange arguments, so I'll leave the link to that also in the description, and you guys can check it out. Talking about practicing problems, you can refer to CSCS problem set. You can again solve the first 50 problems of this section on the searching and sorting section, and you'll be good to go. Right, now before we move ahead, let's talk about the sponsors of this video, which is Geeks for Geeks. Geeks for Geeks has come up with a really fun virtual event called Geeks Summer Carnival. The pre-event of this carnival will be happening from 26th March to the 2nd of April. This event will be filled up with fun, excitement, entertainment, and a lot of games related to coding. And there will be loads of goodies and discounts on various Geeks for Geeks courses that you can win throughout the carnival days. You can even check out their wall of wishes section wherein you can fill up your details and wish for a course that is there on Geeks for Geeks. And if you're lucky enough, you'll get this same course for huge discounts or even for free. In case you have any other doubts, you can check out their FAQs and you can check out this whole event with the link in the description. Moving on to the fourth important topic that you should do in order to reach 1600, it is called dynamic programming. Right, this is a really important topic when it comes to competitive programming or even interviews and coding tests. Right, so this is one topic that you should master. Even if you don't want to reach 1600, you should master dynamic programming. Right, how do you start learning about DP? First of all, you need to be very good with recursion and backtracking. Once you are familiar with recursion, you can learn about memoization in recursion itself. Right, so what happens in memoization is that when we are running some recursive algorithm, there are like a lot of overlapping subproblems that occur there. So when we have the answer for a subproblem, we should not calculate the answer again for that subproblem, right? So that's exactly what dynamic programming helps us to achieve. It just stores the answer of a certain subproblem, and whenever we require the answer for that subproblem, it just returns that without even calculating it again. Right. So let's say now you're done with recursion and backtracking. You also know about memoization. What now? You need to now solve a lot of standard DP problems. And how you can do that? You can refer to this DP section of CSCS problem set again. You can try completing, I would say, 60% problems from here, and you should be really good with DP. Now you can learn some basic ideas about DP with bit masking, some basic ideas about DP on trees. You don't have to go a lot into the depth of DP on trees and DP with bit masking. But initially, if you learn it to a level wherein you can solve problems that are, I would say, 1600 or 1700 rated on Codeforces, then you should be really at a very good point. Now, there is just one more point that I want to talk about, which is that you should not be very, specific about learning how to write iterative DP at this point when you're less than 1600 rated. Because trust me, if you are comfortable in iterative DP, that's the best way to go about DP, right? But if let's say you're not comfortable in iterative, but you're very comfortable in recursive, so there is no need to waste a lot of time and learn about iterative DP, because at this point, I don't think you will ever require things like space optimizations or maybe state optimizations, right? So if you don't require that, then recursive and iterative are pretty much the same. Fine. So if you're really tensed about the fact that you're not very good with iterative DP, then it's not at all a big issue. You can manage it even after you reach 1700 or maybe 1800 on Codeforces. Right. So talking about the resources for dynamic programming, you can start with Eric To's DP videos on his YouTube channel. So he has around, I would say, 3 or maybe 4 videos on dynamic programming, and all of them are very beginner friendly. So you can check that out. Then for practicing problems, you can refer to CSCS problem set and AdCoder DP contest. Now, mind you, again, you don't have to practice all the problems from CSCS problem set or all the problems from AdCoder DP educational contest. From CSCS problem set, you can try out the first 60 to 70% problems. For AdCoder DP contest, again, you don't have to try out all the problems. You can try out, I would say, the first 10 problems on AdCoder DP contest, and you will be in a very good position to tackle a lot of DP problems. Right now, you might get stuck at problems in CSCS problem set and AdCoder DP contest. So for CSCS problem set, you can refer to Karthik Arora's DP playlist. So he has compiled like the solutions for almost all the problems on CSCS problem set. And apart from that, he also has a lot of tutorials on stuff like digit DP and DP with bit masking, DP on trees. So you should definitely check out his channel specifically for dynamic programming. Right. For AdCoder DP contest, you can watch Utkarsh Gupta's AdCoder DP playlist. So he has covered a lot of problems from this AdCoder DP contest. And once you do all of this, you will be in a very good position to tackle a lot of DP problems. And let's say you're done with all of this, I would then recommend you to try out problems that are almost 1700 or 1800 rated on Codeforces, right? Just random problem solving on DP. Right, so moving on to the next topic. Now let me give you a disclaimer. All the topics that I'll be talking about from this point will not be very helpful for people who are less than 1400 rated. So if you're less than 1400 rated, I would advise you to take this with a pinch of salt. Don't specifically go a lot into the details of the topics that I'll be discussing from this point, right? But if you're kind of like at 1400 or above that, then you can, do these topics. So yeah, let's move on to the next topic, which is called trees, right? So how do you do trees? First of all, you need to cover the basic properties of trees. You need to understand how, the structure of a tree looks like. What exactly is a rooted tree? What exactly is a non-rooted tree? Then, what is a parent, a subtree, a child, an ancestor, things like these, right? So there are like a lot of properties. Then you can learn about DFS on a tree, right? And I can tell you from my own personal experience that if you are done with the basic properties of trees and the DFS, you can solve almost 90% of the problems that are less than 1700 rated on Codeforces. And I don't think that for people who are kind of aiming to reach expert, you need to be solving problems that are 1900 rated or 2000 rated on trees, right? But yeah, so if you're done with basic properties and DFS, you will be in a very good position. After that, you can learn a little about binary lifting. So this is like a very important topic in trees. You don't have to go into a lot of details about binary lifting. You don't have to solve a lot of problems on binary lifting. But a major application that you should look at in binary lifting is finding the LCA in order of log n time, like basically finding the LCA of two nodes. What is LCA? LCA is lowest common ancestor. Right. When it comes to practicing problems, again, you can refer to the trees section of CSES problem set. Fine. So yeah, these are the certain subtopics that you should refer to in trees. You can also do DP on trees, but I think once you're done with trees, that is the point when you should actually do DP on trees. So I had sort of listed DP on trees in the dynamic programming section only, but I would recommend you to first of all go through trees and then only go into the DP on trees. Or even if you have to go into DP on trees, then first of all cover the basic properties and the DFS part of trees, and then go into it. Talking about the resources for trees, first of all, I do have two videos on my YouTube channel on trees. The very first video covers the basic properties and DFS, some basic ideas of DP on trees as well. And the second video covers, concepts like LCA and binary lifting. Right, so you can check out both of these videos. And apart from that, if you want to have a video wherein somebody is solving problems and you can solve problems along with them, then you can watch Galen Collins' trees topic stream. You can also refer to Eric To's binary lifting video, which he has on his YouTube channel. So this was like a really cool video that I watched a long time back. So yeah, you can refer to that as well. And for solving problems again, you should refer to CSES problem set. Fine, you should try to solve at least, I would say, 7 or 8 problems from the tree section. Once you do that, you will be in a very good position again, and you can maybe try out 1600 and 1700 rated problems on Codeforces after you're done with all of this. Right, moving on to the sixth and the last topic for this video, which is graphs. Right, so you should be doing graphs at not a very high level, but up to an intermediate level in order to reach 1600. So you should again start with the basic properties like what is a cycle, what is a path, how do you do a DFS, how do you do a BFS on a tree. So these are certain things. If you do these, you will again be able to solve all problems that are kind of less than 1600 rated on Codeforces. You can also look at connected components and also some basic ideas about directed graphs. Right, so I'm not going a lot into the details here because I again don't want you guys to go a lot into the details of graphs. So there might be a lot of people who might reach expert even when they don't know anything about graphs. After learning some basics about the directed graphs, you can learn about minimum spanning trees. So you should at least know one minimum spanning tree algorithm, and you should be able to code it up. You might as well learn Prim's algorithm or maybe Kruskal's algorithm. But the idea about Kruskal's algorithm is that you should also be familiar with disjoint set union. So this is why I've mentioned disjoint set union as an optional topic. If you're able to do it well and good, then I would recommend you to learn Kruskal's algorithm for minimum spanning tree. But in case you are not familiar with disjoint set union, then go for Prim's algorithm. Okay, talking about the resources for graphs, again, you can watch Galen Collins' topic stream. This is like a really cool video, around 3 to 4 hours, and it contains a lot of really standard problems. Right, but again, you should not watch this video when you're just starting out in graphs. Right, instead you can watch William Fissett's graph playlist. So this was something that I also referred to in my time when I was learning a little about graphs. So this is not something that will contain a lot of problems, but it will contain a lot of theoretical concepts. Right. So even before you go on to Galen Collins' topic stream, you can watch William Fissett's graph playlist. And again, if you want to solve a lot of problems in graphs, you can refer to CSES problem set. Try out around the first 10 or 12 problems in it, and then you can get into Codeforces and do random problem solving till I would say 1700 rating. Right. So that's pretty much it for graphs. All right. So now that we've talked about the topics that you should do, let's now talk about the topics that you should not do. Now, it's not like that if you do any of these topics, you will not reach 1600. You might as well reach 1600 even faster. But the thing is that if you waste a lot of time on any of these topics, you will be missing out on the time that you could have spent on the essential topics that I just discussed. Right. So these are certain topics that you should not do at this point if you're not very comfortable with the first 6 topics that I had listed till now. Starting with advanced number theory, there is no need to go for topics like Euler-Tauchian function and matrix exponentiation. And there are like a lot of advanced topics in number theory, like Chinese remainder theorem and stuff like that, even extended Euclidean algorithm. I don't think there is any need for you to do it at this point, right? If you reach expert at that point, maybe you can try these topics. But right now, I don't really recommend any of these topics. Now, talking about range query data structures, I have seen a lot of beginners right now learning about segment trees, Fenwick trees. Trust me, there is no, use of learning segment trees or Fenway trees at this point. You will never be able to use segment trees if you're only solving problems still like ABC, code forces ABC. Once you start solving problems like D and E, that is the time you will require segment trees. But by the time you are able to solve D problem, you would already be above expert, right? So there is no need to do segment trees, Fenway trees right now. There's no need to waste time on that. Again, don't do tries, right? There is no need to do binary tries or like general tries, which are used for string like matching algorithms and like string searching. And again, no, there is no need to do advanced string algorithms. You can learn about hashing, but that's it. There is no need to learn about stuff like AMP algorithm, Z algorithm, or maybe Maneker's algorithm. Again, don't do strongly connected components. I don't think any problem that I've solved on strongly connected components is like less than 1700 rated, right? So there is no need to do that, and it is like a really rare topic. So once you get to a very good rating, at that time you can do strongly connected components, and you will also be, finding these problems quite frequently when you're at a higher rating, right? And then there are certain, advanced tree algorithms like Euler-Tour, heavy light decomposition, and centroid decomposition. I mean, I can tell you from my own personal experience, I have like absolutely close to zero idea about heavy light decomposition and centroid decomposition, right? Then there are like things like square root decomposition. Again, there is no need for you to do that. There are things like Mohs algorithm and a lot of other stuff in square root decomposition. So there is no need for you to do square root decomposition. No need to touch it, right? And the last thing is DP optimization. So I have seen quite a lot of people recently who are coming up to me and talking about things like digit DP maybe, or higher advanced optimizations like convexal optimization. Trust me, there is no need for you to do any of these topics. If you have to reach expert, you will reach expert by just knowing the basics of DP. Even if you know like the very basics of DP with bit masking, DP on trees, that much is sufficient. There is no need for you to do any DP optimizations, right? So these are certain topics. I mean, these are certain common topics that I've seen people doing at this point when they should not be doing these topics, right? So don't touch upon any of these topics. I can assure you, you will never find any of these problems in the first, I would say, the first three problems on code forces, and most of the times even on even the D problem won't be requiring any of these topics, right? So yeah, that was about the topics that you should not do. So yeah, that is it for this video, guys. I hope you all liked it. And in case you did, don't forget to smash the like button below. And in case you're new to this channel, then don't forget to subscribe to it, because I do post a lot of content around competitive programming here. And yeah, obviously, in case you liked some parts of the video, or in case you did not like some parts of the video, then be sure to comment out below and let me know your feedback, because then I can plan out more content accordingly. So yeah, in case you guys would like to follow me over other social media platforms, then yeah, I am really active on Twitter and a little active on Instagram as well. Right. So yeah, that was it for this video, and I'll meet you in another one. So yeah, till then, bye bye.